So in this video, I want to go over some synthesis problems. And what we're doing with synthesis problems is generally you're given the product, and then sometimes the reactant, sometimes just some information about the reactant, and you have to get from point A to point B. But you don't know how many steps it is. It could be one, it could be more than one, it's usually more than one. And then all of the reactions that we've used this semester are fair game for these. So I want to do a couple example problems. There are a few on the practice problems that I have posted on Canvas, the handwritten ones with chapter 11. So I would definitely practice a few of those. They're really a good way to learn your reactions because you have to put them together. So it's not just one, but it's several of them, and you have to kind of think through how we're making them. So I just think they're really good ways to make sure that you have your reactions down. So you'd be given something like this. I have two arrows. That doesn't mean there's two steps. It's just kind of how I'm showing that you want to get from this reactant, my alkene, to this epoxide. And then we have to figure out, knowing all of the reactions that we've learned this semester, how to put it together to do that. Sometimes it's easier for me to work backwards, sometimes I work forwards, sometimes I do both directions and kind of work in the middle. It just really depends on the particular problem. So the first thing I kind of do is I try to analyze it. So we have an epoxide, that's our product. And I think back, okay, what reactions do I have where I know how to make epoxides? And we've only had one. The only reaction where we learn to make epoxides is where we go from a halohydrin, right, where we've had an halogen and a hydroxyl group on adjacent carbons. And then from that, we would add some sort of strong base, and we can get our epoxide. So since that's the only method we've covered, I know that I have to be going through that step at some point. So that's generally my starting off point. If we had a reaction to go directly from an alkene to an epoxide, then it would be pretty, it'd be easy, but we don't. So I know that somewhere I have to do this. So I'm just gonna kind of work it backwards. I'm gonna start with this. I'm gonna pay attention to how many carbons I have. So I have 1, 2, 3, 4, 5. Usually I'll check this also, 1, 2, 3, 4, 5. So I know my carbon chain didn't grow at all. If it did, the only reactions that we've had where a carbon chain grows is in chapter 10. So we made that alkyne ion, right? In terminal alkyne, we were able to deprotonate it with a base, and then we could add that to an alkyl halide. That was our alkylation reaction, or we can add it to an epoxide. But since I have 5 carbons on both, I know I'm not doing that. And then I'm going to draw what I would have gotten before we made an epoxide, so that halohydrin. So I know on here, and often when I'm taking them apart, it looks kind of rough to begin with, but I have an OH group. It's equally substituted, so I could put the OH group on either side to start. Sometimes after you go a few reactions deep, you realize that you needed to have put it on the other side. But I'm gonna start with this, and then actually let's use a real halogen instead of X. So I'm gonna put bromine on there. You know what I mean by we could have put the hydrogen, the hydroxyl group on the other side. I could have put it on this one, and then I would have put my halogen over here. Both of those are options. Remember, when we're forming our group, we actually want the least hindered alkyl halide. It's secondary in both of those, so one isn't particularly better than the other. So unless I can't get my alkene between those 2 carbons, I'm gonna go with this one just because it's the one I did first. If for some reason I can't get my alkene between carbons 2 and 3, then I'm gonna have to go back and look at the other one. So to go from this halohydrin to that, we had to add some sort of strong base. So I'm gonna put a strong base in. I'm gonna use sodium hydride. And then the question is, okay, do I have a way to go from an alkene to this halohydrin? And we actually do. This one is from chapter 10. So bromine, and then water. oftentimes it's more than 2 steps, but this one was just 2, right? I can take my alkene, we can add bromine and water, we end up with a halohydrin, and then it's an intramolecular SN2 reaction once we deprotonate it, right after we deprotonate it with that strong base to get that. So another example, so we're going to start out with ethyne, so my 2 carbons and my 2 pi bonds between them, and then I'm going to end up with 2 different ketones. So this one, that is supposed to be on that carbon, sorry, and this one. So I guess a couple real obvious things. One, my carbon chain grew, right? I started out with 2 carbons, and I end up with 1, 2, 3, 4, 5, 6, 7 carbons plus that methyl group. 1, 2, 3, 4, 5, 6, 7 carbons plus that methyl group. So we know we did an alkylation at some point, right? Because my alkylation is going to grow my carbon chain. The other thing I would notice is that it's a ketone, right? And we've only had one way to make ketones, and that's hydration of an alkyne. And we could hydrate it 2 different ways, right? If we had an internal alkyne, we could use the mercury sulfate, sulfuric acid, and water, or we could use the hydroboration oxidation reagents, right? If it was internal, either one of those would work. One follows Markovnikov's rule, the other non-Markovnikov's rule. But since it's equally substituted, we're going to get the same product. So I'm going to work backwards. I'm going to draw that alkyne. I'm going to notice that my carbonyl on one of these is on carbon 3, and my carbonyl on the other is carbon 4, which means my triple bond is going to be between carbon 3 and 4. So I'm going to draw that out. So this is going to be carbon 1, 2, 3, 4. Then we need the rest of it. That's going to give me 5, 6, 7. Let's double check though, because I tend to lose them. There we go. And again, you can use either the mercury sulfate, which is what I'm going to write, or you could use the hydroboration oxidation reagent. So that was the BH3 THF in 1 step, so you need a 1 in front of it. And then in a 2nd step, so number 2, hydrogen peroxide and hydroxide ions. So 1 step done. The next thing I'm going to notice, right, so I started with 2 carbons and I end up with 7. But I know that I can't just add 5 carbons to it, because if I did that, it's actually going to be on the end, right? If I was to take, just kind of as a side note, if I was to take this alkyne and we add a base, so it's charged, right, we deprotonate it, and then I do my alkylation reaction with an alkyl halide that has 5 carbons, 1, 2, 3, 4, 5, and then we're going to do our SN2 reaction, and I'm going to end up with that group on the end, right? Because my halogen was in the end, it's a substitution. And it's not, it's in the middle. So I know that what I probably had was 2 alkylations at some point. One alkylation I put this on, and then in the other alkylation reaction, I put that on. So I'm gonna have to do 2 of them because it's in the middle. So working backwards, I'm gonna do the base and the alkylation kind of in 1 step. So I'm going to do 1, we end up deprotonating it. Let's actually draw. It doesn't matter which half you do first. I'm going to put that 2 carbon group on. I guess first or last, I'm going backwards, one could say last. So remember, we started with this, and then I have to add a base to remove that proton, and then end up with, it's skeletal structure, so I'm not going to draw it, but end up with that negative charge. And I'm just going to do it in 1. So I'm going to do 1, that base, it's now charged. And then 2, an alkyl halide that has 2 carbons, because I'm adding these 2 carbons to it right now. So I have 1, 2, and then that's going to grow that side. Once I have that, I'm just going to do another alkylation. So I'm back down to my I'm taking off this other group. So that's going to be what's attached to my halogen. And then I'm doing both steps again. So in the first step, we're going to add a base. Oops. And if you want to write that out separate, you can. And then that alkyl halide. You can use chlorine instead of bromine if you want, or iodine. And then that gets us our synthesis reaction. These would be good too to practice mechanisms if you wanted, now that we have the reactions. So you would do your deprotonation in SN2, deprotonation in SN2. This one you didn't have to do the whole mechanism for, so you could just skip that one. But it would be cool to draw the enol intermediate and then see how you're getting both of those ketones as your products. So another example. So I'm going to start with an alkyne again. And then I'm going to put the ketone, but this one I'm going to put a hydroxyl group on. Whoa. So I'm going to have a hydroxyl group there. So carbons, I'm starting out with 3, and we're ending up with 1, 2, 3, 4, 5, 6 carbons. So we did at some point go through that the alkene anion to the acetylide ion. And then I know this is one where I might kind of work in the middle. Like I have that ketone on, so I know it probably went through some sort of hydration reaction. So if I was to go through that, and it's not real clear where it went, so we can draw 2. I'm going to try first of all putting the alkene or the alkyne between carbon 2 and 3. It could be between 1 and 2. We don't really know right now because I'm only given one of them. So I'm going to start with it between 2 and 3. If that doesn't work, then we'll try the other way. So I'm going to draw out this part. And then if I'm going to put that alkene between carbon 2 and 3, it's going to go here. And then this is carbon 1. We should make it a little bigger. So 1, 2, 3, 4, 5, 6 carbons. My other option, let's just draw it. I would have this part still the same. And then I'm going to put it here. So we would have, 1, 2, 3, 4, 5, 6. Notice this numbering is not for naming it. If I was naming it, I would have to number from the other side because I want a number to start closest to the hydroxyl group. Remember, if we have an alcohol, that's our highest priority group, so that's always going to get the lower number. So I'm not numbering this for naming right now. I'm just numbering it so I can keep track of where everything goes. I started numbering in that direction because I started numbering this one up here. And a ketone is actually a higher priority group. So in 236, when you learn to name ketones, that is the correct way to number that original one. But I just want to keep my numbering scheme the same, even though my ketone's now gone, because I'm not naming it. I'm just trying to keep track of all my carbons. So I'm just going to keep this in the reserve as something that maybe we want to go back and look at. The reason I did it the way I did the first time is because of this, right? This alkyne has 1 carbon on the one side. So that's that. If I do it like this, I don't really have a way to get it on. And that might not be something you notice at first until you've done a lot of these. So I know my first one's actually the correct one, but just kind of like if you were doing it, you might come up with both of those. Okay, so now this is kind of where I start working forward, and I don't always go forward, but this one, the reason I'm going to is because of that part that I just highlighted and then unhighlighted. I know that that's that end. So if I add, maybe we'll do it separate this time, my NaH, I have this. And I have an alcohol there. So the question is, okay, what reaction do I have where I can do that? And we actually have one. If I add it to an epoxide, I'm actually going to get that as my product. This one's probably a little bit harder because the epoxide thing is weird to look at, but I am just doing an SN2 reaction, but it's between my acetylide ion and that epoxide, and that gets me that product. So these arrows don't really go here. So this one for us. Example. So we got this, and I'm going to go to this one. So again, I really just kind of start by analyzing it. So I'm going to notice that my carbon chain didn't grow. I have a cyclopentane, but then off of it I have 2 carbons. So I know that didn't change. So I'm not doing an alkylation. I do know that I have an aldehyde though, and I know that the only reaction that we have where we get an aldehyde is if I add the hydroboration, oxidation reagents to an alkyne. And it has to be a terminal alkyne, so I know that I had that at some point, right? That's how we get an aldehyde. So then my question is, okay, how do I go from this reactant to that alkyne, sorry. We only have one way to make an alkyne, so I guess that's where I'm going to go. That one way is where we add 2 equivalents of a strong base, so whatever strong base of your choice, and then we started out let's actually put an actual halogens on there. We started out with 2 halogens on adjacent carbons. So what this is just a double. It's not even really, I don't know if double works. It's like an E2 times 2. I like that better. E2 times 2. Right, we're doing an elimination and then another elimination. So I know I can get my alkyne from that, but that doesn't do me any good yet because that's not that, right? Even if I put bromine, let's do bromine just so you can see my problem. I mean, I think we're making progress. We're not at a dead end. It's just that it's going to be a lot more steps yet, right? If I put bromines on there, I have bromines on those 2 carbons. Here I only have, right, on my reactant, I only have a bromine on the 1. So the question is, okay, well, how do I get 2 bromines on there, right? Well, I know I can get bromines on adjacent carbons if I have an alkyne. Sorry, an alkene, alkyne. I keep getting those guys mixed up today. Probably not just today. I know if I have that, and then I add Br2, keep in mind my stereochemistry on this, this guy is not cool, but we're just going through the steps, right? Those 2 bromine would need to be anti to each other. So this, if this was coming out, this would have to be going back. So then the question is, okay, we can get from here to here, right? If I have an alkyl halide, I can get a pi bond. I just have to do another E2, just a single E2. So instead of 2 equivalents of my base, I just need 1 equivalent. I'm gonna use hydroxide this time. You could use a bulky base, right? This is just straight out of chapter 8. So I have a secondary alkyl halide, I have an alkyne, so this is just going to be an E2 mechanism. So again, this one was kind of a lot of steps, and like I didn't have a clear path as how to get from point A to point B, but I just kind of worked it backwards, and eventually it kind of worked out. So I just looked at this first one, and I was like, okay, I know I'm not alkylating, so just get that out of my head. I know I have an aldehyde. This is the only way I know how to make an aldehyde. Right? We start out with a triple bond. We add this stuff to get an aldehyde. It has to be a triple bond. There isn't anything else that's going to get us that aldehyde. And then the question is, okay, I'm not starting out with a triple bond, but now I have one, so how do we make one, right? We have to be able to figure out how to make that. Well, I only have one way to make a triple bond, and that's adding 2 equivalents of base to a molecule that has halogens on adjacent carbons. Okay, so we did that, and then the question is, well, how do I get halogens on adjacent carbons? The only way we know how to do that is if I add Br2 to my alkene, I keep saying that wrong. I just actually thought of another way to do that as we were taught. No, sorry. I thought I had a way to do it. Sometimes you're going to do this because I just did it out loud in front of you. If I was to take an alkyne, I actually mean an alkyne this time, and then add 2HX to it, I actually get the halogens on the same carbon, not adjacent carbons. So that wouldn't work neither. So this is the only way I can think of right now where we would get that based on the reactions that we have. And then, okay, well, how do I go from my reactant to this? Chapter 8. So again, it's taking stuff that we know and stringing it together into one big problem. At first, they're probably a little frustrating, but I think if you just kind of dig in, if you just stare at it and try to think of the entire path before you start working on it, it's just going to be frustrating and not going to happen. For me, I would just get overwhelmed. I'd be like, I don't know how to do that. You kind of just have to dig in and start. Just do one step at a time. And then once you start getting close, you're going to be like, oh, okay, I know how to finish it. So definitely do some practice problems. Again, there's some in the book that might be a good place to start, and I do have some posted for you on Canvas.